Hello class, in this video I will be doing two examples from section 7.3, basic probability. While we do these problems, please make sure that you are referencing this chart that I gave you in 7.3. Okay, a card is drawn from a well-shuffled deck of 52 cards. Find the probability that a red 7 or an 8 is drawn. What I'm going to do is I'm going to label this event E, and then I'll label this event F. From the notes, we know that the probability of E or F is the probability of E plus the probability of F minus the probability of E intersect F. Now, I'm going to ask myself, is it possible to select a red 7 and an 8 if only one card is drawn? And the answer to that question is no. So the probability that E and F occurs is 0. The probability that you select a red 7, that is 2 divided by 52. The probability of selecting an 8 is 4 out of 52. So the probability of a red 7 or an 8 is 2 divided by 52 plus 4 divided by 52, which is 6 divided by 52, which is a probability of 3 divided by 26. You may leave your answer as a fraction or a decimal rounded to 4 decimal places. Next question. A queen or a 2. Again, I'm going to label E for 2 and event F for a queen. Just like the previous problem, if you select one card, it is impossible for that card to be a 2 and a queen. So the probability of selecting a 2 is 4 divided by 52. The probability of selecting a queen is 4 out of 52. So the probability of selecting a 2 or a queen is 4 out of 52 plus 4 out of 52, which is 8 divided by 52. And when you reduce that, it will be 2 divided by 13. Question C. A black card or a 5. So again, I'm going to label this E, and we're going to label this F. And is it possible to select a black and a 5 if one card is selected? And the answer to that one is a definite yes. In fact, there are 2 black 5s in the deck. So the probability of selecting a black card is 26 divided by 52. The probability of selecting a 5 is 5 divided by 52. But the probability of selecting a black card and it's a 5 is 2 divided by 52. So the probability of the union is going to be 31 divided by 52 minus 2 divided by 52, which reduced is a 7 divided by 13. Okay. Last question. 2 dice are rolled. What is the probability that the sum was greater than 8 or the first die was a 4? Just like the previous problems, I'm going to label this event E, and I'm going to label this event F. And if you look at the chart, there are 2 options for the dice to sum to a number greater than 8 and the first die is a 4. So the probability that the sum is greater than 8 is 10 divided by 36. The probability that the first die was a 4 is 6 divided by 36. And the probability that the sum was greater than 8 and the first die was a 4 is 2 out of 36. So the probability that E or F occur is 10 divided by 36 plus 6 divided by 36 minus 2 divided by 36, which is 14 divided by 36, which is 7 divided by 18.